Hello, 7th graders. This is Chapter 8.5a, Square Roots. We're going to take a little bit of a break from area and circumference to work with square numbers and square roots in anticipation of working with the Pythagorean theorem. Today, we are first of all going to talk about a perfect square. Now, a perfect square, yes, that can be a polygon with 4 sides that are congruent and 4 right angles. But numerically, it's really a number that is the square of an integer. So for example, if we take 0 squared, we will get 0. 1 squared means 1 times 1, so we get 1. 2 squared means 2 times 2 or 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 25, etc. And I've included here a list of the squares of the numbers from 0 through 15. And then showed you 20 squared, which means 20 times 20. So the 2 times 2 is 4, and then you're going to have 2 zeros. 30 squared is going to be 3 times 3 is 9. And then you have 10 times 10, which is 100, which is why you have 2 zeros. So if you had 40 squared, that would be a 16 followed by 2 zeros. Now, these particular numbers that I have listed here, the 0, 1, 4, 9, 16, 25, etc., those are what we actually do call the perfect squares. Now the square root is the inverse or the opposite of squaring a number. There's a symbol, and I show it to you in the notes here, that indicates square root. Now on a computer or a calculator, it isn't going to look like that, and I've showed you the symbol that is often used on calculators and computers. So we are going to simplify some numbers here. We are going to take the square root of 49. That means that the square root of 49 equals 7, and we think 7 squared equals 49. So if we have the square root of 64, what number times itself gives me 64? Well, that would be 8. The square root of 49 over 64. Now sometimes students are all shook up. But really what this means is the square root of 49 over the square root of 64. The square root of 49 is 7. The square root of 64 is 8. So our answer is 7/8. So if we would take the square root of 121 over 169, we're not going to go to that second step. We're just going to say to ourselves, okay, the square root of 121 is 11. The square root of 169 is 13. How do I know that? I gave you a list. The application. What happens here is that they are going to ask us to use what we know about area and square root to find out about the lengths of the sides of squares. The area of a square cover for a whirlpool is 144 feet squared. So what is the length of each side? Now, normally, we would find the area of the square by taking side squared. So if I take the square root of the area, that's going to mean s, because the square root of s squared equals s. Just like the square root of 4 equals 2, the square root of 9 equals 3, the square root of 16 equals 4. I'm going to start out here, though, with my formula. The area of a square is side squared. This time, though, if you look at the problem, they tell me the area. It's right there. That's 144. That's going to equal the side squared. I'm going to take the square root of 144 is going to equal the square root of s squared. Now here's where I use my reflexive principle, and I say, all right, so s is going to be 12. In this case, I'm measuring in feet. Okay, let's look at another problem. Area of a square park is 36 meters squared. What is the length of each side? Okay, the area is side squared. A equals area, I know that, 36. I don't know the side squared. Well, the square root of 36 has to equal the square root of this s squared. The square root of s squared is s. The square root of 36 is 6, in this case 6 meters. The other skill they're going to ask me to work with, or ask you to work with today, is estimating square roots. What do I do if I have a number and it's really not on my list of perfect squares? For example, if we look back at that list of perfect squares, they tell you that you have 36 and you have 49. There's no place where they tell you 40. So the best thing we can do is say, all right, I need to find the square root of 40. I can't do this unless I precisely use a calculator, which they don't want you to do at this point. You have to do some thinking. I look at my list of perfect squares. 40 is between 36 and 49. So therefore, the square root of 40 has to be between the square root of 36 and the square root of 49, or 6 and 7. So if they want me to find the square root of 40, I say that it's between 6 and 7. Let's look at the square root of 96. Okay, I look at my list of perfect squares. The one that's smaller is going to be 81. The one that's larger is going to be 100. So therefore, the square root of 96 is going to be between those two numbers. So it's going to be between 9 and 10. Let's look at C. The perfect square that is smaller than 136 is 121. The one that's larger is 144. So the square root of 136 has to be between there. So it will be between 11 and 12. And that concludes Lesson 8.5a on square roots. Please respond with the word squares. Catch you later.